Yep, I'm live and the music is also on. Okay, screen is not stuck. Everything seems to be fine. So I'll just continue and yep. Yesterday we had created a HTTPS server projects CD HTTPS server uh, server.c. This is the file that is handling the HTTPS server. And what do I want to do today? Well, first of all, I would like to understand how this SSL thing is working. OpenSSL is handling the TCP connection and all that. Maybe not in the whole detail, but let's see how far we can go. And let me just test the server once. The server is listening. And now Postman. Yep, Postman is starting to listen on port 443. See, where the heck is Postman? It is here. And yes, DDNS is not working due to some reason. Yep, HTTPS and my domain and send. Do I get something? Yep, I do get something. I get hello HTTPS. It says this. Unable to verify first certificate. Okay. 0 SSL ECC domain security site is local address is this. Remote address is same as local address. TLS protocol is the latest, which is 1.3. TLS cipher name, which I do not understand. Oh, okay. This is the cipher. Okay, this is the algorithm that we have settled on. SHA-256. Okay. Certificate CN. Issuer CN, who issued the certificate 0 SSL, and it is valid until June the 16th. That is also cool. Now, what do I want? I guess certificate unable to verify first certificate. What is that about? Okay, I need another Chrome tab at some place. ChatGPT. Yep. I see. I have created a HTTPS server using OpenSSL library and I am sending a request to it, but on the client side I see unable to verify first certificate, but the connection is done and the client and the server are talking just fine. See, they're unable to verify this first certificate. Means that the client does not trust the server's certificate because it cannot find a valid certificate chain leading to a trusted root certificate. Since your server is working fine otherwise, this likely means that the server's certificate is self-signed or issued by an unknown certificate authority. The server is not sending the full certificate change, meaning the client cannot verify it. The client does not have the correct CA certificate to verify the correct CA certificate to verify the server. Steps to fix: check what your server sends. Run this command to check the certificate your server sends. OpenSSL this thing. Show certs. this thing, and I see a bit of stuff. Protocol TCPL. Look at the output. If the server's certificate appears and not an intermediate CA certificate, your server is missing part of the chain. I see quite a bit of stuff. What does this supposed to mean? What is this supposed to mean? Depth 2, internal security certificate, begin certificate chain, and then end certificate, begin certificate, another certificate starts. No client certificate CA names is sent. I guess there is some problem. Server dot end server dot c, and maybe the name of this full chain and duck DNS org key, cert file and org key are these the only things that I have to give to the server. Yep, full chain and private key, SSL certificate and key, full chain and org key. What are the other things that I can give? Slash full chain dot cert config key. Yep, that seems like the thing. Or maybe CA dot cert. Let's see. Client server dot c JSON server. Yep. Nope, this is not that. Client server dot c. Send the output to server. OpenSSL does not exist. Okay, I have to use the OpenSSL linker. It is, yep, GCC command or something. Server. Certificate mismatch. So that was a mistake. It seems I have to change this back to full chain. GCC. And this long command means that I am including the OpenSSL libraries. /server.c. Wait, or instead of using this whole command, I can write it in a small shell script. Yep. Okay, and copy this thing and do echo this thing into make dot sh and then sh make dot sh. That should work. That does work. /server, running the server, send a request. Hello, HTTPS. That should have worked, but it does not. Okay, something is happening with it. Maybe it is establishing some connections. Started to listen, but nothing went there, nothing went through. If I close the server, it is still trying to send the request. Server.c. It is full chain now, and port is 443. Everything is same as it was. /run the server again and stop and send. Maybe since the server is stopped, it is trying to connect in the same way that it connected it for the first time. Okay, yes. In HTTPS, does a new TLS connection gets established So for every request response cycle, or or after the first request response cycle, the same key and algorithm is used for a certain amount of time. Okay, a new TLS connection is not established. Instead, once a TLS connection is established, it can be reused for multiple requests depending on the factors like connection persistence, session resumption, and keep alive settings. Okay, maybe here it is trying to no, don't save. I guess the problem is that here it is trying to access with the earlier TLS connection. Therefore, now it should work. Maybe. HTTPS to the yep. It was trying to establish a connection with the earlier TCP TLS keys and algorithms. So if I were to stop my server and run it again in a while, maybe now, shit. I have to come up with a better way to stop the server. TLS handshake first request. A new TLS connection is established. The client and server negotiate a key exchange algorithm like RSA. Okay, they generate a shared session key for encryption. They agree on a cipher suit. Yep, something like this. The session key is used to encrypt the connection. The session key is used to encrypt the connection. Yep, subsequent requests, same connection. If the connection is kept alive, the same TLS session continues without a new handshake. The same session key and encryption algorithms are used. HTTP requests and responses are sent over the existing encrypted channel. Connection closure. If the client or server closes the connection, a new TLS handshake is required for the next request. Some servers close idle connections after a timeout. Keep alive timeout in HTTP. Okay, now if I run the server and send a request, I should maybe not see. I do see a response of something bad was happening the first time. Factors affecting TLS reuse, HTTP keep alive, TLS session resumption, HTTP 2 or 3 multiplexing conclusion. Now I want to go through this thing and see how this is actually working. Okay. This whole part handle client from this 235. This whole part is TLS, has to do with how TLS is implemented, and also these two files. They tell the full certificate chain and the certificate key, then init open SSL, then open SSL load error string function is called, and then open SSL, and SSL algorithms are called. SSL, what the heck is SSL? Secure shell is SSH. Is SSL and TLS. SSL secure socket layer and TLS security layer are cryptographic protocols that secure internet communications, ensure data privacy and integrity. A client and a server through TLS, though TLS is the more modern and secure successor to SSL. Okay, so TLS was used before, now it is SSL. Okay, SSL was used before, now it is TLS. For encrypted data transfer, earlier used SSL, but now TLS is in use. Yes. Earlier, SSL security layer was used for secure sockets layer was used for encrypted data transfer, but it has been replaced by TLS due to security vulnerabilities in SSL. Why was SSL replaced? SSL 2.0 1995 and 3 1996 had major security flaws, including weak encryption and susceptibility to attacks like Poodle. Uh-huh. TLS 1. Should I learned about different attacks which were written in my router? I forgot. TLS 1999 was introduced as an improved version of SSL. TLS 1.1 2006 and 1.3 in 2018 brought further security enhancement. Why is TLS better than SSL? The stronger encryption, faster handshake, better resistance to attacks, forward secrecy. That is okay. So SSL RFC latest would be about 1999, 1996. SSL secure socket layer. This was written in 2011. SSL version 3. Right, this is something that I can read. Yep. Okay, I'll read it later, of course, not now. SSL. Okay, so first there was the SSL algorithm which was used for encryption, but there were vulnerabilities in that algorithm. Therefore, TLS was introduced. Okay, first of all, what is the difference between the two? And yeah, the basic technology, I suppose, is the same. So the basic idea behind both of these, I suppose, is the same. That is an encryption algo is algo and key is agreed upon, and that is used for subsequent requests. The manner in which they are agreed upon and the complexity of the algo might change depending on the protocol, but in both, this is the basic idea. Let's see. And that is right. Both SSL and TLS serve the same purpose: secure communication over a network by encrypting data. The core idea in both is the handshake phase. The client and server agree on the encryption algorithm, cipher suitable selection, a shared key for encryption. Data transfer phase. Once the key is established, it is used for encryption and decryption data in subsequent communication. Differences between SSL and TLS. The way they agree upon the key exchange mechanism has evolved. TLS supports better encryption algorithms and removes outdated cryptographic techniques. TLS 1.3, it is not even a major update from the first one. TLS 1.3 simplifies the handshake, making it faster and more secure than previous versions. At the core, both do the same thing: agree upon a encryption key first and then use it for agree upon encryption key first and then use it for further communications. That makes sense. And there are libraries that implement these. Does OpenSSL implement TLS or SSL? Yes, there are several libraries that implement SSL slash TSS, TLS, and OpenSSL is one of the most widely used. There's the OpenSSL implement SSL. OpenSSL originally implemented both SSL and TLS. However, since SSL 2.0 and 3 are obsolete, OpenSSL dropped support for SSL in newer versions. Modern OpenSSL versions from 1.1.0 onward only support TLS protocols. Yes, in Postman it said the same right here. It says TLS protocol 1.3. Right, these OpenSSL versions after 1.1, no SSL support. Right. Alternative libraries, let's see, GNU TLS, GNU TLS, MD. What is the TLS library? Let's see. Kernel.org. Got it. The Linux kernel archives. I have this is the archive. Git.kernel.org. Yep. There must be a network folder which is net.net slash that is biggest GitHub tutorials and folder. Yeah. If onto that is for Bluetooth, I suppose, or Wi-Fi or something. Advanced Bluetooth. TCP as it's a TLS at some point. It's such TLS. TLS is static. TLS handshake args. Internet TLS handshake. I don't even know what I am looking for here. Okay, it's fine. One is the language. Because it is in boot. OpenSSL. OpenSSL, yes, is a library used to establish. Explain to me all the steps used in using OpenSSL and all the steps used in using. It's still not working. It is, I guess, horrible. As for me, it's not functioning. Yes. Used in using OpenSSL to establish a TCP connection. What does each function call does, and what do the arguments mean? Let's see. Establishing a TCP connection with OpenSSL involves a series of steps, including setting up a socket, initializing OpenSSL, and creating a TLS SSL context. TLS SSL context, that is like sort of environment in which the connection, in which the algorithm and the key will be stored, and handling will bring on the process with different OpenSSL for that argument to establish a secure connection using OpenSSL. Which is TCP. I just my bad. TLS. TLS. TLS connection. Steps to establish a TLS connection with OpenSSL library, create a context, create a socket, and connect to server, create an SSL structure, and get to the socket, perform the TLS handshake, send the data over TLS, and shut down the connection, and clean up page. Okay. So initialize OpenSSL library. Okay, initialize OpenSSL library. Before using OpenSSL, the library must be initialized. Before using OpenSSL, the library must be initialized. Second, load error string OpenSSL and algorithms. This loads OpenSSL, TLS, SSL algorithms, loads error messages for debugging, stores cryptographic algorithms, and all OpenSSL and all. Okay, so this loads TLS and SSL algorithms. This loads cryptographic algorithm, and this loads the error messages. Okay. Aren't these, what does it mean to load them. Are they not already? Are they not a function? Are they not like a are they not like functions which can just be called by the SSL lib by the OpenSSL library whenever needed, right? The functions might not be a part of the OpenSSL library, but if OpenSSL library has them in its header file, then they will be loaded by the loader at the compile time. When we talk about loading SSL algorithms and error messages, we're not referring to loading functions in memory like the loader does at runtime. Instead, we are referring to initializing internal data structures and OpenSSL. Okay, initializing internal data structures in OpenSSL, which will be used to store stuff needed. Why do we need to load the Okay, does it mean initializing algorithms or loading algorithms? Because these two things are different. OpenSSL is modular. It supports multiple cryptographic algorithms, ciphers, and it is a thing specific to OpenSSL. Well, of course, it supports multiple cryptographic algorithms, ciphers, and protocols. These are not all automatically enabled. Okay, string errors need to be mapped. SSL load error OpenSSL using numerical error codes, and string error maps them to human readable strings. Cryptographic algorithms require initialization. Some require pre-computed tables or initialization steps before they can be used efficiently, breaking down each function. OpenSSL init. The function initializes OpenSSL algorithms such as this. Initializes 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 protocol versions like this and this, etc. Without calling this, OpenSSL might not work correctly because some structures would remain uninitialized. Okay, so the function that actually implements as of OpenSSL when this is no longer needed because OpenSSL auto-initializes itself. This OpenSSL errors are error code. Example, this function loads human readable error descriptions into memory. Without this, print this would output error. This routine, this verify field, if not called, you might see error. This which isn't useful. OpenSSL all algorithms, registers, cryptographic algorithms, and digests with OpenSSL needed when using OpenSSL's high-level EVP API for encryption and hand hashing. Cipher into this EVP cipher type, a pointer to EVP cipher type equals EVP get cipher name for this thing. If so, why aren't these just available by default? Yep. Efficiency. OpenSSL supports many cryptographic algorithms, but loading them all unnecessarily would increase memory usage. Modularity. Some applications only need specific ciphers and hash functions. This allows selective loading. Legacy supports some functions were optional in older versions of OpenSSL. In this, these functions are no longer necessary because OpenSSL automatically initializes itself when needed. If you are using OpenSSL, this you can skip these part. OpenSSL now ensures everything is set up internally. Okay. what does it mean? So, what does it mean? Since the total amount of algorithms that OpenSSL supports is very large, therefore these functions are used to selectively load them, and loading them means initial initializing some data structure which stores a pointer to the function which implements these algorithms. Storing which implements these algorithms, error messages. Is that it? Mm-hmm. Loading them means initializing some internal data structures that store information about the available cryptographic functions, including pointers to their implementations. How does OpenSSL manage algorithms? OpenSSL maintains a registry or table where it stores a mapping of algorithm names to function pointers. This allows OpenSSL to dynamically select the right function at runtime. Algorithm specification metadata information such as key size, block size, and flag for each cipher or hash function error code mapping. Numeric error codes are mapped to human readable strings, and breakdown of what happens when you load algorithms. Breakdown of what happens when you load, aka load algorithms. Cryptographic algorithms are called this function. OpenSSL registers all available encryption, hashing, and signing algorithms by inserting function pointers into an internal lookup table. Mhm. This allows functions like this to work. Example: internally, OpenSSL might create a table like this, where RSA points to a pointer, which function pointer, which pointed to a function which can be used. Yeah. Error messages: when you call this, OpenSSL loads a mapping of numeric error codes, human readable. An example of internal mapping is, okay, this is not rendered correctly. Here, this thing maps to this, and this number maps to this. Load error is not called. You might get a numeric code instead of a meaningful error message. Why not always load everything by default? Performance consideration. OpenSSL supports a large number of cryptographic algorithms. Loading them all upfront increases startup time and memory usage. Customization. Some applications may only need specific algorithms and want to avoid unnecessary bloat. Security. Some outdated, less secure algorithms like MD5 is outdated. Well, it was written in 1991 by Ronald Rivest. RC4, I don't know about RC4, should not be loaded unless explicitly needed. Does OpenSSL load these automatically? Yep, now it loads them automatically. Okay, are these algorithms implemented by OpenSSL itself, or are used from some other library? In OpenSSL, most of the cryptographic algorithms are implemented by OpenSSL itself, but some are delegated to external libraries or hardware acceleration backends. Here is a breakdown of how OpenSSL handles algorithm implementation. OpenSSL implemented algorithms. OpenSSL provides its own implementations for a wide variety of cryptographic algorithms. This stuff is quite a bit of stuff is handled by OpenSSL. These implementations are written in C and are compiled directly into the OpenSSL library. The OpenSSL library also provides an API to access these algorithms in a standardized way, such as through EAP API, which abstracts the underlying algorithm specific details. And backends. Although OpenSSL implements many algorithms itself, it can also leverage external libraries or hardware acceleration for performance improvements or security reasons. Some notable examples include hardware acceleration like AESNI CPU and CPU features. OpenSSL can take advantage of hardware features available on modern CPUs to accelerate cryptographic options such as AESNI. Intel Advanced Encryption Standard new instruction new instructions, okay. ARM Neon based, okay. Neon is the ARM's Neon is Apple Silicon's ARM based extension for implementing SIMD instructions. These optimizations are done through ng modules which allow OpenSSL, okay. Hmm. Let's see, how can I use OpenSSL algorithms setting up OpenSSL like this? Then import all this stuff, then combine OpenSSL algorithms. There are we main all algorithms. Ensuring is protects its key. Saying ensuring via AES performance CBC mode. Not a random byte is I suppose the function this time bytes put random bytes into key. Okay, and how long is the key size of key? Yep. If not random bytes, okay, if none of this happens, then do this. Okay, and I am also putting random bytes into IV AES advanced ES block size for CBC mode. I don't know what CBC mode is. EB cipher context. Okay, let's just move on to understanding OpenSSL. We now know initializing OpenSSL. This part is used to load libraries, error messages, algorithms, and stuff. Load SSL TLS algorithms. Create a TLS context. Context SSL context defines the TLS configuration. This equals in a context pointer which is created by SSL ctx new SSL context new TLS client method. TLS client method. What is TLS client method? Okay, whatever. And then create a new client TLS context if acting as a server. Use TLS server method. How? And I guess I must be using TLS server method because I'm acting as a server. And this optional load certificate is for mutual TLS if needed. Do I do that? Of course, I also do that at some point. Yes. Okay. These are the functions. Here I first create context. Create context is a function. Yes. Anyways, I am creating context and returning it. Then configure context, in which I'm loading the certificate and the key context, and then integer serverability. Okay. This part, if used, if client authentication is required. Okay. What is a context? What is a context? What is a context? Let me try to understand it myself a bit. SSL context new, that is a function that creates a new context, whatever that means. And TLS client method, it returns something which specifies whether if it is a client or a server. Context, what is a context? Does it refer does it refer to using the data structures. And does it refer to using the data structures that were initialized in the last using the data structures that were initialized in the last step to store to make them into a, bigger coherent data structure into a bigger coherent data structure, which will be used for algorithms and key lookups, when the when the server and the client communicate. And yes, and one context is attached with and one context is attached with one, you could say, with one context is attached with one identity in a sort. Context is attached with one identity. That means that on the client side, on the client side, uh, on the client side, different contexts can be established in a single program, but they will appear to the server as different clients. And on the server side, they'll appear as different clients with their own with a different key and algos. And on the server side, with different contexts will make separate TLS connections. Yep, they will make separate. Each context will have its own TLS connection with every other context. Mhm. Okay, and contexts are needed to group the error messages and algorithm suits into a more coherent structure. Different contexts use the same data structures that were initialized in the first step. And now everything is wrong. You are totally wrong. Yes, you are on the right track. What is a context? In OpenSSL, a context SL concept refers to data structure that holds the continuous state of your TLS of particular TLS connections, client or server. Okay, from the client side, it only makes one connection, but from the server side, a single context can be used to make multiple connections. And even on client side, I can use a single context to connect to multiple servers. It is essentially a container for the settings. Yes, container for the settings, certificate, keys, and various cryptographic parameters that will be used during a TLS handshake and communication. Key points about context. TLS configuration. The SSL CTX defines how TLS connections should behave. This includes specifying the TLS version, Supported cipher suits, certificates, and keys. Shared settings. The context allows settings like certificates, uh, keyless configuration like algorithm suits, certificates, and keys on the server side, and the same things on the client side. Yeah, the client also saves the certificate for the server that it is connecting to. Shared settings. The context allows settings like certificates and encryption algorithms to be reused by multiple TLS connections. The context allows settings like certificates and encryption algorithms to be reused by multiple TLS connections. Yes, it's to be reused by multiple TLS connections. This is what setting up these parameters. Server and clients. They are context creation methods for the server and the client, ensuring that the TLS configuration matches the role. Okay, context in the flow of communication on the client side. Multiple contexts can be created in a single program, but each context can represent a separate TLS connection to the server. Yep. Even though the context might share some of the same underlying data structures like cipher tools, each context will have its own set of parameters for things like certificates and keys, if different credentials are required for different servers or sessions. Hmm. Hmm. Okay. Multiple clients. If you need to maintain different sessions with multiple servers or clients, each connection can use a distinct context. While they share same common algorithms, they could each have a unique certificate and key. Connection identity. Each SSL context object has to maintain the identity like certificates. Each SSL context object helps in identity like certificates and the settings for each connection. This ensures that each context is treated independently during the handshake and data transmission phases, even if they are used within the same client application. Yes, so every context has its own certificate, key, only a single key, and algorithm in the client side. All right, okay. The set power contexts are also possible. Each context will represent a different set of connection settings. For example, if the server handles multiple protocols or client certificates or client certificates. In most cases, a single server context SSL context CTX is used to handle multiple connections. In most cases, a single server context is used to handle multiple connections. You can create different contexts for different protocols or types of clients. Types of clients, that is racism. Separate connections. A server can handle multiple TLS connections, each with its own context. A server can handle multiple TLS connections. A server can handle multiple TLS connections, each with its own context. Although the server might use one global context, it would create different SSL connections. Connection objects to be used tied to different SSL contexts for different connections. For example, for handling mutual authentication or different cipher suits. Mhm. Although the server might use one global context, it could create a different SSL connection objects tied to different contexts for different connections. Grouping of error messages and algorithms. Error messages. Each context can maintain its own error messages. These messages typically represent problems that are during the TLS handshake. SSL context provides a mechanism for grouping these algorithms by context in which error occur, making grouping and algorithms with the supported cipher suits. Key exchange algorithms and hashing algorithms are defined at the context level. This means that when a TLS connection is established, the context will be used to select the right algorithm for the handshake and the session. Example. Here, context is established, then load server certificate and private key. Mhm. Okay, I guess this much I can take. All right, this much I can take, but this much load server certificate. I guess this format of studying is not fast, but it gives me deep understanding. So if I'm going to learn like this, that is things in detail, then I will have to give more time than a normal person would to studying. But it is like, what else do I have? Load server certificate and private key. This is a context you certify. Description that answers to this context. This is the file path, and this is the file type PEM. This tells that the file type is PEM, and this does the same thing. It puts into this context this file, and this is the file type. Check. Okay, is that the problem? Yep, that is the problem. The file type is not PEM. Is it NC? Uh, let's see if it has the one. It says it is CER. I don't know what is the make error, not slash, so error. Error. So okay. So it is PEM after all. PEM, and this is PEM. SH make SH not slash sir. Now it is working. Okay. And if the private key is correct, not private, check the private key in this context. If not, then print private key does not match the public certificate and exit. Now the server is ready to accept connections within this context. Okay, and this creates the new context. This and this load the server's certificate and private key into the context. This context will be used to handle multiple cases from clients, each of which will use the same set of certificates and keys unless configured otherwise. Each of which will use the same set of certificate and keys. Okay. Context SSL in OpenSSL is a structure that holds the configuration and state of TLS connections. It helps to reuse settings like certificates, private keys, and reuse settings like certificate. Each context can have one certificate and one private key. Supported algorithms across multiple connections. Contexts can exist for multiple connections, ensuring constant on state and identity. If that's what I used earlier. That also helps to manage error messages, algorithm routes, and other settings for a coherent connection handling process. Okay, that makes some sense. So.c. Here's the thing that has next. Here I have opened initialized SSL and created a context. And okay, so that means that I have covered all of this part. That is cool. Now, basically creating a server and binding the server, printf that server is running, and do that. Now, initialize the server and stuff. Yes, let me get into initialize the server. I didn't go into much detail earlier when I was working on that. Server.c. Here, okay, these are the functions which I have created. Now here, yep, ignoring all the thread stuff. This is how I'm going to do this. Okay, init server FD. It is a socket. It is a socket. Wait a minute. Yep, it is a socket, and integer server FD file descriptor of the socket. It stores the file descriptor of the socket. Okay, now we can get into how to create a HTTP server using sockets. To create a HTTP. Is this redundant? Have I already? Nope, I have not gone into how this socket things work. Only like I only have my own speculations and some detailed view of stuff. So let me first in the and first initialization. I did my comedy. I might like Thor, and if you know, then you know. Initialization then is context that you want to that I wanted to context. So in this in the interface, what we do is we load a normal and stuff and this algorithm and also algorithm for crypto encryption. And what we load is messages. And what does loading mean? Loading is a structure that is because and if OpenSSL were to store pointers to everything, uh, or it were to include all of these things, that is it is selecting what is loading. That is the load step. The stuff I have loaded in this, I am finding it all together and creating loading. Creating a big structure that's these stuff that are loaded, and also its other stuff that is these the actual algorithm, the function, and stuff like that. That is context free questions. Now that that is done, I can use this code to establish connections. Now I have to speed up. It's how to be created, which because that means I have created a TCP and the TCP connection is written in HTTP format. So what is it mean to establish a TCP connection? Yeah. So I on my computer and I have a number which points to socket. You can think of this number and the music is stopped. If I start the music, it's time. That that seems fine. That much volume is going to tell minus 50 decibels. Okay, minus 50 decibels. And yeah, sockets. I have this F and that which point me that socket, and listen that I start on incoming connections on that socket and the data that is stored. I can fetch it. I can store see it and as HTTP format specifies it. In this here I have created an integer which points to an integer called server FT, which stores the server. Yes, and then I initialize a structure called socket address init 6, which contains details about configuration details about and I can add stuff to it. How do I add stuff to it? In this, I've done this address length. This is total length of bind address, and then I create a socket in the socket program. I wanted to create a IPv6 socket and a socket team. This must mean something. Of course, that stream. I guess that means I want to create this socket over TCP, and 0 also must mean something. Then I edit the configuration or the address, and then I bind them. So it means after creating and the configuration, I get some configuration and full after getting full socket and seeing if it actually bind this socket with this thing. This much is contained in this configuration structure, and then I listen on it. Listen on this socket. Backlog refers to how many subsequent sockets, like while you are processing the request input from one socket, from one TCP client or something, then how many of them, how many can you keep at bay so that you can listen to them later when you're done with the current one. Then get it thread. Yeah, and the main is you call which function you call pthread create handle client function. Yep, handle client function. This function takes in a client FT must create here client FT except on this socket and except on the socket anything and put the address in this, and this is the address length, and give me the client FT, the ID of the socket, ID of the receiving socket. Up socket. Do I get auto suggestion? No. Do you think then? Esoteric? Well, not esoteric. Everyone has a connection, multiple welcome. In setting up a socket from the client, side, first I initialize an integer that will store the socket descriptor which I can use to do stuff with that socket, and I also initialize a structure called address or something. A structure called, it seems so illegal to use mouse on Vim. It is called this thing, socket address in or something, which stores in the config for a socket, and then I bind the socket with the config the config structure. Then I bind the socket with the config structure. Yes. Then I bind the socket with the config structure. And what else do I do? I bind the socket with the config structure, and then I can establish. Wait, what do I do on the client side? It is in YouTube stuff, I suppose. Client RC. Yep, all of that, and socket server address. Here I'm creating config file for the server. Okay, right. I'm not binding anything with anything here. I'm adding a step about the server. Okay, that is. Yeah, I just initialize a socket. Okay, like that, and then I added configuration about the server, about its IP address and port number. About its IP address. No, IP address will be given in IP. Where am I using server IP here? I'm using server IP here in this part. Okay, init p10 and init p10. What does it do? It stores server address into server address. Okay, because I do not know the address. Yeah, this is a call to a DNS server. Get the IPv6 address for this server and store it into this configuration. Then connect this socket with with the socket which has this configuration and the size of that, and then print out. So the binding stuff does not happen on this part. Configuration for I also initialize a structure called socket address in, which stores the configuration for the target socket. It stores the protocol and the port and also address and all the address. Since only the domain, since mostly the domain name is known, therefore a function called Python, init Python is called with the config and the domain name which adds the server's IP to the config structure, right? And then a connect function is called. Then a connect function is called with the client socket descriptor and the server config adder file. Let's see. Don't have this setting episode on the client side. Here's a big create socket P with which means and this must mean something. And this returns a subject which will be used in subsequent operations. And this specifies, this specifies before, and this specifies TCP. The protocol is automatically chosen based on the socket layer stream. Okay. Setup address in this structure holds the information needed to connect to the target server, including the server's IP address, port, and protocol. Like this stuff. Instance ATT. Convert the domain name to IP address, port number ATT. Your domain name is provided. You use inet ptown to convert the domain name into an IP address. If the IP is already known, you can directly assign it. The inet ptown function converts an IP address from text to binary format. Inet ptown function converts an IP address from text to binary format. IPT converts the domain name example.com into a binary IP address stored and stores it in the server file. Connect to the server using the connect function. When the server configuration structure is properly set, and I can use a connect function, that is connect this socket with this, and then socket empty is the socket descriptor. Yep, and this casts the server address to the generic structure address type, which it already was to begin with. So it was in this, and when it was created, it was in it initializes it to 0. Server address initializes the whole structure into 0. Add in, and this converts it into a generic structure type. Okay. I can use send and require. TCP. This is just a web socket. Then I send to through the client ID. Send this message, which has this much length, and then I read. What do I read? Read whatever comes into this. And this is the size of the buffer, and this is where you have to read, and this is the size of the buffer, right? And this returns the number it has read. Buffer then received from server. Okay, that makes sense. On the server side, I initialize a socket descriptor for the server and a socket and a config structure for the server itself, and then I bind the two together. I'm listening on it, and then I accept anything in that structure and store the details into the client address and store the FD in client FD. And on the server side, I have to create a socket and store its descriptor and create a adder structure for the server socket and add config details to it, and then bind the two together, and then bind the two together, and then bind the two together. I also have to initialize a descriptor for another socket which will be used for connection with a client, and also its config structure. On the server side, the server socket is used to receive connection requests, but then for every new client, a new socket is opened for communication. A new socket, and using the descriptor for that new socket, I can send and receive messages on that connection, and after a connection is established, the interface to send and receive messages is the same for both the client and the server. Mm, It is just that the client uses its own client socket descriptor for the purposes, and the server uses the newly created client socket client sockets descriptor client sockets descriptor for its purposes. Let's see. For example, the detail for server. Create a socket to server speed socket use for incoming requests from the client. Create a socket and check it if it is okay. If inet says that I'm using IP4 and socket stream says that I am using TCP socket. Setup address socket address in structure. The server must create and initialize a socket address in structure to specify the address and port on which the server will be listening. Like this, accept socket connection from any address. Isn't this the error which says that you cannot take incoming requests from anywhere? What is that called? Is shit. What is that error called on web when it says that you cannot send or receive, when your server cannot receive requests from just anywhere? It's when it receives a request from a IP that is not whitelisted. Nope. It is called shit. I forgot. It is from like something said something that starts with C. Express is rejected. Error. Error C. Request not handled. C. Error. Request from only only called Corsair Express course. Okay, setting up address, right? Allow request from any bind the server to the socket address. The bind function binds the server socket to the specified IP address, and this allows the server to listen for incoming connections on that address and port. Bind takes in the socket. Yep, binds the size of the address structure. Listen for incoming connections. Binding the socket, the server starts listening for incoming connection requests with the listen function. With the listen function, it specifies a backlog, which is the maximum amount of pending connections the server can queue before accepting them. Right, is taken in the server FD and the backlog. The same amplifier in this case is the backlog size. Accept a connection from a client. The server uses the accept function to accept an incoming connection from a client. The accept function returns a new socket descriptor that is used for communication with the client. That is why the server creates a separate socket descriptor for each client. Creates a separate socket descriptor for each client. Structure socket adder, and this is the link socket T and in the client socket, right? And then this makes it the code that I have written has some error. Since here I am initializing it, right? This is this is the server side. So yeah, pthread threads client fd, it's client address. Yep. I have to change this. I have to put client address in here inside every loop. Song adder, song adder in of client adder, and uh, sock len t adder length equal size of client adder, right? And unknown type of doing so. Oh yeah, misspelled items. And here I just remove this and socklen. Yep, that seems more correct. Navigation with the client. Now that the server has a socket descriptor, can use descriptor to send and receive messages that use its own communication. Send a message and from process of connection and closing the socket. The server uses one socket to listen for any requests. Upon connection, the server creates a new socket specifically for communication with that client. Both the server and the client use send and receive to exchange messages with the client using its own after communication. Each ends the server closes off client socket to free sources. Let me know if you need any further clarification. That much makes sense. That much makes sense. So that is what is happening in this part. After initializing and creating context for OpenSSL, I do something. I create a socket for the server, right? A normal socket which is like at this point disconnected and does not know about any TLS connection or anything, and there is no TLS connection established. Interstellar music frames have dropped now. After this, after I have client socket and a TLS context, what happens next? I accept, I accept that I did. I accept that any incoming request on server FT, but why are both of these? Why those fields are used to store information about the client, so storing information about well then if there is nothing, then I just if there is an error, then I continue. That is I start up. That is cool. And then I create a new SSL connection with the given context. Okay, and then I do SSL set FD. Alright. With this new SSL connection, this new connection apply. This is a new pointer which I will SSL point connection pointer which I will be using for whatever I have to do next. And so I do set SSL connection on this socket. That makes sense. Set an SSL connection on this socket, and on this side, if SSL except if there was a connection established on this SSL, then voila, I'll handle that connection. Handle SSL. Otherwise, print an error. Okay, and how do I handle that connection? And God, to handle that connection, I just do this stuff, which is I take in a buffer SSL, which is reading normally, and then if bytes is greater than 0, right? That is if I got something good, get good. If I got something good, then I do print what I received and I write, which is SSL write, send it through the SSL connection string. And what is the length of this string? It has a length 50. And then shut down SSL and free SSL, which are different due to some reason. And then at the end, close FT. That makes sense. That much actually sense. After accepting a connection and not storing anything about client, I create a new SSL connection. I create a available data structure which will store details about SSL connection on that context. And then I establish a SSL connection on the client, and then I do check if there was a connection proper, and then I do this handle buffer and do stuff with that. Instead of using this, I can write my own dynamic get function which gets a request of any size, and instead of this, I can write my object function. So I do just that headline. Yeah, I can just change the implementation of the handle line totally. Copy this handle line, put this code after this and the handle line. At this point, it will not take stuff like this. Right, client pointer client point I only that dynamic request will contain request, which is something that is defined. Let me use the buffer for the client server, which is number 20. Request, which is like this, and I can just store it here. Go here and leave the function on client activity, but on SL, right? Initializing request. Why is a problem? Initializing a request with an expression of invalid type int. Okay, and dynamic dynamic request, which is this. Dynamic request that will dynamically as well integer. Nope. What is the type for SSL? It will take in SSL pointer. It will be called SSL, right? Configuration directory. Conflicting types for dynamic directory. Okay. I have not established anything called dynamic directory yet. Right, that's it. So dynamic size. Okay, let's define this. And define for size to be 1024. And shit, it does not have any spaces in between. Buffer size and yep, and instead of requi, I will be using SL on the line model. Call to undeclared function SL read SL is capital. Zero function. Okay, it's not taking the limit, and then it does this, right? It initializes a reallocs new and creates new data structure that has more memory, and then in couple is complete. Another function that is because if the receive of it is complete or not. What it takes in a request, wanted to a request, conflicting types for a request, it takes in data and total size. What does it mean? It takes in the natural phase and problem. Let me find true and not 2.0. It wouldn't matter any jar. And go there and define that function also. Okay, that which is dynamic medium, so that works. So dynamic let's call it read is a SSL dynamic read. SSL dynamic read, and I'm using SSL function. Okay. And in the top, let me change the name SSL dynamic read, and below SSL dynamic read. Okay, my bad. Dynamic read. Yep. And handle client. Here, get response. Get response is not a valid function. I have to create that. So I read this and put the thing at the end of handle client instead of returning null. Close it up, nothing, and nope, nothing. Wait. Handle client function. It gives it the threads I would have to manipulate it. Okay, and yeah, so get response function. Get response. This not the whole thing, but just and define it here. Let's say go to the top and define it here. Get response. It returns something like that. Not I have to put JSON stuff. Copy this, go to the top, paste it. Header file not found. And that is common. cp/http server /c json dot everything, and json. Put all of that into this folder. Yeah, wait a minute. Yeah. You guys cannot seem to hear the music for some reason. Also, I have to disconnect these. But because it is not good, and I'll be right back. And happy and yep, me and I was running. I don't know. Yes, server.c. I'm now writing, copying the function which I created in my own HTTP server to get a response, and here I use the send write function, and this put on this, and then close SSL is not writing down, but for writing SSL, what all I doing there visually. Wait, these are not aligned properly. Yep, now it is better. Shit, nothing is aligned properly. Now it is fine. Right. Create context, handle kind. It's dynamic. Read and not close, just this. Not that is too harsh. Sending field. Yep. Shut down. Shut down would be a better option. Right, and remove that. Right. Now let's see. Let's see. And I have to add something to the make.file. Server.c and c json.c. Is it make.sh? No such file. cjson.c isn't there. Oh, the whole thing is capital. cjson. Wait, no, there is actually no file. cp http server slash c json.c. C. Shit, am I stupid? I'm cp server dot c json dot c to this folder. Now maybe message log 10 math explicitly seal server dot c int content length explicitly provide a declaration of log 10. Okay, I did not include the math libraries. Not this, I'm going to go to server dot c. Yep, I have to include math library. That should be fine. And message make.sh to the server. I'm thinking else add this piece and let's send some stuff. And I do get something. HTTPS is fucking working now. I can send and receive HTTP requests. This is amazing. And I do it. And some body raw JSON type thingy. Key value high, which by send to get a response and it should be printed here. Yep, exactly. That is cool. What is I create a server in which I can receive response dynamically, that is the response of any length, and also send any response very easily using a JSON library which I have found out on the internet called CJSON. And to establish and maintain TLS connections, I am using cthread. No, I'm using an OpenSSL. And yes, now I want to add thread functioning in my server. So n.c, let's add threads also. Include p thread.h and handle client. No, I suppose to handle client in that case. Whenever I see a connection, I will put it on to another client. I will point to another thread, but yeah, then Yeah, I will put it on to another thread whenever I see a incoming request. Okay, so serverability, yeah, that much, that all of that not change. But what will change? I'm using client FD here. Okay, and I'm getting a new query every time. And yes, after accepting this, I want to create new threads and just send this off to another thread. So yeah, for that, what do I have to do? I have to initialize threads. Yes, and how many threads? P thread P empty threads and threads, and how would I know which one is empty and which one is not? All of them. Right, and what is the actual number thing that this thing stores? It stores something for int I equals 0, I less than 10. Wait, stupid. I can record this, which will give me a 10 array which contains 10 empties. So p thread t pointer is a return type get threads. It will take in nothing and return threads. And this has to be malloc. Shit. Since yeah, because it will go out of context. So, and then at the end I will have to free it. That is thread t pointer is equal to thread t pointer malloc what 10. Wait, it take integer input n and n multiply by size of t right, and for n equals 0 n I plus do is I equal to null. Is that right? And then return threads everywhere. Yep. And of course there is at the addition at demand. So t threads equals get threads function 10 threads you and after getting 10 threads, what would I do when getting a client accept? I want to find a thread is empty and pass to it the client function. Fucking hell. Yep. Okay, I guess I went offline on my own and at the end of the stream. Yeah, fine. People exit. Exit is written nowhere. It's just bringing stuff out of my ass now. I'm creating context. I'm creating a socket file through and then after accepting this thing, I want to pass it on to a function which takes in a client socket and establishes an SSL connection and does all things. So yeah, and it can call the client function in itself. Yep. Function that what will return nothing and handle SSL and it will take client FD to an integer. Since this thing client FD is wait, it can take client FD. That is wait, no. Because since the while loop will start again, then this thing will be lost. So I have to create a context that is upper than that. Indeed, client FD it has 10 examples. This everything is 0. And in that array, I have to go some index I. What is that index? How do I figure that out? I can write a function for that. I will return an example for it. It will integer pointer array and client fd. And yes, I would like to store this thing at some different point as a macro. That was pretty stupid. Count connection count. Let's say it is 10 to begin with, right? And when I'm calling the thread function, I change the connection count and also in here connection count and yep for this for int I equals 0 I less than count I plus if client bracket I equals 0 equals -1 return I otherwise it -1 that is nothing. Okay. So in this at this part copy this and store declare this function here, and below then define index get client index d, right, and use index and yep, after this point, after checking the text, and only do all this if index not equal to -1, only then do all of this stuff, and then what is if the below in analysis function, right? Client fd takes in a pointer to an integer. No, this just takes a pointer to an integer. That sense in 32 below I can, since it is defined, I can call this and s I want to pass it in integer, so address client fd index, right? I get an equivalent address, right, and here client id equals go to client fd, not client id but client d. D is cool. CTX, what is the context in which I want to handle this? So CTX will also be passed. What is type of CTX? Is a SSL CTX pointer. Okay, that makes sense. SSL CTX pointer. SSL CTX, okay. SSL CTX pointer, omitting the SSL CX pointer. Yep, that is correct. SSL CTX pointer, that is a valid type. SSL CTX pointer. SSL CTX pointer. Yep. Omitting the parameter in question, this does not match what is defined above. Okay, I got this. Right, and I will see error in my main function. Yep. This also wants some CTX. I will provide in the CTX. Right, and this it will be CTX. Right, and client does not exist. Now what exists is client D. Right, I establish a connection with that thing and close the client FT at the end. Not exactly, but client D. Close that at the end. This thing can handle proper SSL connection and everything. Right, and that is one right. Or slash. So, there is a problem. Through the while loop again and again, which is the actual point, right? Print this index, get client index, and if index is not equal to -1, do this. Yes, it will of course be not equal to -1. Print hi, not client sh not sh, and then on the server hi. Should I see hi? I should see hi, but not due to some reason. I send the request. Not achieve is not received. So yeah, no, I'm not in print hi report. I didn't go through the while. Why? Right, I entered this, then I created this, and then it should have written hi. We're handling SSL connection, and I would right, and then SSL connection. For this, I would like to do client FD go to at that point and change that. Client FD go to that point and change it. I should do hi. As nearness SS kaput. So see the music. That is the end of the stream, and I will manage this stuff on my own. And tomorrow maybe we will be able to get a request from Google.